My name is Abhijit Bose. I head the enterprise AI/ML platforms and engineering for Capital One. We have a few Capital One folks here as well. We are responsible for strategy development and execution of our enterprise AI/ML infrastructure, which powers most of the AI/ML applications at the company. Here is a quick look at the agenda. I will start with a few slides on AI at Capital One. It's actually a 10-year journey for us. It's been, a series of innovations we have done over the years. I would say transformations that led to this moment, where we are at the frontier of AI. And then, core to our strategy, there are two things. The first one is the custom AI. A lot of companies are using AI, but core to our strategy is how do we build custom AI that run in tune with our infrastructure, that run using our own customized models. And then the second part of our strategy is the AI platform. And in this presentation, I will focus more on the AI platform. There is another big conference going on this week, which is NeurIPS. If you follow NeurIPS, you can follow some of the Capital One talks by my colleagues there. There you will find out more about our customized model and that custom AI strategy. But in this talk, it will be more about the platform and infrastructure. I will also go over a particular case study that's, I think, on a lot of people's mind. How do we deploy agentic coding tools? But the way we are deploying it is actually using our own platform to deploy that with the right set of guardrails, with the right set of gateway that actually makes it much more well-managed and scalable throughout the company. And of course, none of this would be possible without having great talent. I'm really fortunate to have such wonderful, extremely exceptional, talent at the company. So I'm going to focus on a couple of things we are doing to really be at the forefront of AI, so that we build a brand name, so that we can attract the best talent in the world to work with us. But first, I want to share some quick context about Capital One. We are a 30-year-old, founder-led Fortune 100 company. The founder-led is really, kind of important for me, having come from Facebook. Our founder, Rich Fairbank, works very actively, hands-on with us on our AI strategy, and that actually has made my life much easier, and a lot of other AI leaders at the company. We are just fortunate to have such a forward-leaning and very innovative CEO at the helm of the company. We are also the nation's largest direct bank, and along the way we have been recognized as one of the best places to work. But I'll just draw your attention to two. In the last 3 years, we have been number one in talent in the Evident AI Index that actually takes in, I think, 50 or 60 global banks and then rates them on their AI maturity, talent, how responsible they have been in deploying AI at the company, etc. And then the second one is that this just came out recently. We are now top 10 companies in the world, along with Google, Microsoft, NVIDIA, Samsung, in terms of the generative and agentic AI patents. All of this is to say that just to highlight the focus on innovation and the relentless focus on developing and attracting talent at the company. So, it's not a surprise that we are at this moment of AI transforming so many, businesses, so much of society. But our history as a technology innovator actually positions us really well. Before I go to the next slide, but the foundations of our company are built on our heritage of data-driven decision-making, modern tech stack. We have our in-house data science and engineering talent. We are all in the cloud. I joined the company in late 2020, and that was the year we got out of our last data center. I still remember we celebrated that. We have been in AWS primarily since then. We have done a lot of work in transforming our data ecosystem at the company. And as you know, your data advantage is really your AI advantage these days. And then we have a history, very rich history. We have a DNA of enterprise platforms. We don't do bespoke application development at the company. From data to AI to cloud, wherever we see a common pattern, we build platforms that everybody in the company uses. And AI is no exception to that. And then, of course, we are exceptional at risk management. But this does not happen overnight. This takes, many years. As our senior leaders say, it's a lonely journey with a lot of hard work. And for us, it started almost 10 years ago. And I'm not going to go through the timelines, but you can see those, like from open source to declaring we were all in the cloud, to getting out of our last data center in 2020, launching Capital One software, where we took some of the capabilities we were building in-house for ourselves. We saw an opportunity to actually take those to the market for other businesses, other companies. And that actually brought a very different perspective to our software engineers and product managers, because now we are not just the customer, but we are more service providers. So things like multi-tenancy became very important for all of us. Even in the AI platform, I remember the first kind of the impetus for multi-tenancy started, when Capital One Software started working with us, and we realized that not all of our platforms and capabilities were built for multi-tenancy, and now every capability that we build, it has to be multi-tenant, because someday we might actually externalize that service to other customers. Now, we in late 2024, we started kind of the groundwork for building our first agentic application at the company. And then in January of this year, we launched our first customer-facing multi-agentic application called Chat Concierge. I'm going to briefly talk about that. And that, again, was a pivotal moment for us. This is the first time a bank really exposed a multi-agentic system in front of live customers, live in the market. We learned a ton from that. And as I will show you, we took all the lessons learned, and then we kind of like reformulated our platform plans, and now we are all in agents and how we scale agents at the company. We are also using AI extensively at the company for all kinds of applications. Here are some examples. I already talked about the multi-agentic AI workflow called Chat Concierge. We also use AI for real-time fraud detection and mitigation. Many of you are familiar with transformer architecture. We use transformers these days to personalize user experiences on our mobile and web pages. If you use our Capital One shopping plugin, it uses AI to find the right offer for you from the right merchant as you are checking out your SKU. And then if you use our Capital One Auto Navigator app, it uses image recognition to find you the right card that you are looking for. Again, those are by AI, I mean not generative AI. A lot of these are neural nets, but more and more we are also using LLM-driven and agentic AI systems. Now, let's talk about where we are going with AI at the enterprise. Now, we all realize that AI is not just a new technology. It is going to fundamentally change our business, fundamentally change our processes that we use at the company. Now, when it comes to scaling AI at any large, regulated industry like ours, I think all of us have to deal with two things. One is the need for speed. Every other day there is a new something happening, new model coming up, or some inferencing, algorithm optimization comes up. A lot of work is happening in agentic coding tools. We are seeing real benefits. So there is a lot of pressure on all of us to actually bring these tools into the company and deploy them. But we also have to make sure that all these tools are well managed. We have zero tolerance for cyber or risk failures, and we have an exceptionally high bar on those. So how do you build at the frontier of AI at the speed of well managed? That is the core problem statement, I think, for all of us. Those who work in large companies and regulated industries, we have to deal with. Now, before I go to the next page, I want to define the speed of well managed, because that's also something we learned. It's not the speed that we were used to maybe even 3 years ago. With AI, we also have to lift our risk, cyber, governance, all of the controls that we deploy, all of the audit functions in the company. So the speed here is also increasing. It's not just, AI is moving fast, but my processes are still slow. That's not going to work. So how do we lift all boats? That's the core, of the problem statement. Now, to us, to build that company that innovates at the speed of AI, but also at the speed of well managed, it comes down to these building blocks: proprietary data, cloud and serverless, GPUs or compute infrastructure, modern tech stack, enterprise platforms, I'll mention about that, in-house talent, risk, governance, and then the last one is model customization. It's not just using the third-party frontier models that are available at an API, but the companies that are going to be at the forefront of this, they will leverage their own data to build LLMs from scratch and customized for various specialized tasks at the company, and they need to have the infrastructure and talent to then deploy them at scale at the same level of sophistication as some of the frontier model companies have been doing. Now, as I said, we set out to do all of those through two things, customized models, and now I'm going to come to the enterprise AI platform part of it. Now, we have been building this AI platform for last 4 years, and we have learned a lot. We have redesigned a few things over the years. But a couple of basic principles have stayed the same. For example, for the best AWS services, we take them, we build on the shoulders of them. So for example, EKS, ECS, SageMaker, Bedrock, OpenSearch, EFS, S3, FSx for Lustre, for high performance file system for GPU cluster. We have taken them, but we have also built a lot of other capabilities on our own. And then we have also incorporated a lot of open source projects into our platform. So this particular combination of AWS services, open source, and our custom proprietary capabilities, that actually has helped us to be at the forefront of AI. And we are at a stage now where we can mix third-party and first-party capabilities almost interchangeably into our stack to be very quick and fast in deploying a lot of capabilities at the company at scale. If there is one kind of nugget of information I can give you is that being able to design a control plane, being able to design a stack where you can bring in these three things easily in a well-managed way, that is something people should take on, because it's not just about depending on a vendor for everything. It's not about building everything on your own, then we'll miss out on a lot of the innovation. And then it's also not, open source is not enough in many cases. So in the next few slides, I'm going to talk about two things, two parts of the platform. One is the model training, or our training infrastructure, how we build using, again, three different pieces of capabilities. And then, very importantly, the inferencing capabilities. So if you think of the modern GenAI stack, you have to have a really well designed training infrastructure, and you need to have very well designed high performance inference infrastructure. Of course, traditional core ML had that too, model training and model inference. But in case of LLMs and generative AI, it is really complex, much more complex than what we have dealt in the past for core machine learning. So I'm going to talk about our HPC clusters. It's been about, I would say, maybe 2 years, and we learned a lot. At the basic level, it's basically compute, network, and storage. And you could say, how difficult is it? You get your compute from AWS, you get your storage, you get your network like EFA, storage like FSx. But we find that you need to build a lot of additional capabilities on top of that to be really at the the kind of at the bleeding edge of building very large models that where nodes fail all the time. You don't want to waste these GPU resources, which are very expensive. And you also have to invest in your training pipelines, so that those are also very efficient. So this is what we did. we took the infrastructure, a lot of it from AWS, native, capabilities. That's the left-hand side of the slide. Things like high-speed networking, scheduling and queuing, high-performance file system, GPU nodes recovery, etc. The software stack, the heart of the training pipeline, and these are training pipelines that need to run, jobs across many GPUs, hundreds of GPUs, or sometimes thousands of GPUs in a distributed way. That was mostly open source and our own custom pipelines, and we tuned that to the hardware. And then the third one, the thing on the right, user experience, a lot of that we had to build all by ourselves. So this is a perfect example of you can build, world-class infrastructure with combination of AWS, open source, and your own stack. And all of this has been built by our own in-house AI researchers and engineering team. But we didn't do this, in a day. It was really a learning experience for us. We did it in 3 phases. In the first phase, we got a lot of the infrastructure procured and provisioned by AWS. In phase 2, we focused on our training pipeline and really building that in-house knowledge of how CUDA kernels work. Even debugging GPU, like training code that runs on GPU is very complex. So we had to build a lot of that expertise in-house. And then in phase 3, we started to become more and more sophisticated. We focused on minimizing downtime. How quickly can you checkpoint restart a job that has failed on one GPU? And so you can think of this as a journey that you have to go through. And it took us probably about a year or so to get really to the point where we are now. And this is kind of the training infrastructure that looks today. I will tell you a few things that at the top, you see the diversity of the users we support on this training infrastructure today. And this is not just one cluster. We maintain a few different clusters, for custom built for certain kind of jobs like RL, versus like post-training RL versus like pre-training or specialized transformer for certain, applications. But there are a whole range of users with varying knowledge of infrastructure, but they don't have to deal with much of the complexity of a GPU cluster today. Thanks to a lot of the abstractions we have built in how you submit a job, how you debug, etc. It's also built for multi-tenancy. We can stand up a cluster for a certain application, certain division within the company, where there may be strict data, restrictions. And again, as I mentioned earlier, multi-tenancy is kind of in our DNA now after Capital One software. And then at the bottommost layer, we have the data layer where we can bring in data from Snowflake. We have a pretty large Snowflake footprint. We have S3, we have other data lake, and then, of course, a lot of the data need to come into FSx to feed the GPUs. I'm going to talk about next our model hosting and inference. And this is something, again, a lot of you have realized this, is that training cost is kind of like fixed, or, once you have trained the model, you have incurred a certain kind of cost. But your inference cost is just starting at that point, right? And if you are not careful with your inference platform, that itself can be a huge expense. You are not going to get the kind of the economics of this token or per query right. And as a result, what worked for 100 users as a prototype, you will find that that doesn't work when you have to support 100 million customers with that GenAI applications. And when you hear, a lot of GenAI applications are dying at the POC level, one of the reasons it dies, is that people haven't thought through how to really develop the infrastructure and how to really create the cost structure to scale it to millions and millions of customers, millions of tokens per minute, for example. So we took this very seriously. In our first iteration, we put together a system that worked. It supported a smaller number of users internally for an internal application. But for us, it was existential that we have to get really world-class in our inference platform capability. So there are three things here. First is the cost per token or cost per query at scale, unit economics. Then the user experience, latency and throughput. When we first deployed the chat concierge, and I'll get to that in a couple of slides. Chat concierge we had, because it's multiple agents, multiple LLM calls, I remember we were getting something around 40 seconds from the point you ping you put your query, and then the system will come back and answer, give you the answer back in 40 seconds. Now it's about 1 second. So that did not happen, without a lot of the optimizations in our inference stack, on our model customization stack. This is why, it's not just about AI, but it's custom AI that you have to figure out what works for your own enterprise. That's where the leverage is, and that's where I think things are heading. And of course, reliability. If you're going to maintain a large fleet of GPUs for inference, uptime, dependencies, and how much you can pack within each GPU, how many inference calls, those things start to matter. Now, we faced a dilemma, and I think it's very common for a lot of companies who are experimenting or deploying GenAI, and I'm sure some of you are familiar with this, that should I go to a managed provider, I get an API, I get Llama or Claude or a lot of different models behind an API, and I get started right away. So I have huge velocity, and I pay by tokens, right? So if my usage pattern is variable, it makes sense. You can pay by usage. And then, of course, you'll be trading off on data privacy. You have to audit them. You have to make sure that they are not using your data for training, or there is leakage going on somewhere, exposing user level information outside. And then even when you go to a managed provider, depending on your scale, as you are going from like 30 users dog fooding to 1,000 users to 1 million to 10 million to 100 million, at some point you will find that, okay, this economics probably does not work for me anymore because I'm paying so much for my tokens all the time. So then the other side of that is the self-hosted option, where you have to have now your own DevOps team, your own AI engineers. You have to get GPUs provisioned. There is a fixed cost to all of that. And the answer for us was that, like many other choices in life, it's actually both. So we have been able to design a control plane where we actually host a third-party, platform for certain types of use cases. And then we also host our own platform, inference platform, where we can really optimize end-to-end, like our own custom models, our own inference stack, our own hardware provisioned to really optimize the latency, throughput, and cost. And these are some examples of optimizations that we have done in our in-house self-hosted inference platform. I talked about model-level optimizations, but we have also done a lot of infrastructure stack optimization, which is basically how do you maximize the GPU usage by bin packing, by putting multiple tenants on the same GPU, but then you have to worry about data separation, query separation, and all of that. You have to build those systems, but we have been able to get orders of magnitude lower from where we started, about a year ago on this optimization work to now where we are, to the point that we feel that we will reach a level that's comparable to any other provider outside. And in fact, that's our benchmark. Like if we can get as competitive as any other, like OpenAI, Anthropic, GCP, or Bedrock, we need to be in the same league there. Now, I'm going to talk a little bit about Chat Concierge. So I talked about the LLM training, LLM inferencing, but then as we are building those things, there are also agents story happening in the broader GenAI ecosystem. So in 2024, we started working on our first kind of use case. It's for consumers. When you go look for a car, a lot of dealerships offer you a chatbot, and you can interact with the chatbot. You can say, I'm looking for a, whatever car, this color, this model, do you have it in your inventory? So we have a very, well-established auto business, very forward-thinking auto business. It's not the traditional auto lending. We also work with a lot of dealers to build a lot of the dealer backend software platforms that go into lending, maintaining the dealer websites, a lot of the capabilities that dealer need to interact with customers. So one of the ideas was that, can we build a chatbot on top of our AI platform that will be hosted on our platform, but there will be a little chat window on dealer websites, and then prospective customers will be interacting with it. But then our agentic framework on the Capital One side will actually do the actual conversation. So that's the product. It's called Chat Concierge. Now, to build the product, we did a few iterations initially, but then we landed on a multi-agentic framework called Macau to build this, and I'll show you a little slide on Macau next. But then we also had to build a lot of the, vertical stack to support this agentic application. For example, we used TensorRT for LLM hosting for that. We used Llama and then fine-tuned Llama models for the task. We had to build some custom guardrails. Chat Concierge today is on many dealer websites, and we have very aggressive ramp-up plans to many hundreds and thousands of dealers. If you get a chance, you can play with it on the web. But this particular agentic framework turned out to be a very general purpose framework where we start with an understanding agent, that starts interacting with the customer to understand the intent. So for example, if I say I'm looking for a blue BMW, to figure out that I'm looking for a car called BMW with color blue, that's the understanding agent. Then it passes off that information to a planner agent, which does some planning. And then that planner agent hands it off to an evaluator agent that has access to a sandbox with a bunch of APIs with some synthetic data to do a simulation, essentially, to figure out, is my answer or reply going to be correct? And then once it's satisfied, it hands it off to the explainer agent, which then frames the code and the output of the evaluator agent in human language, so that the customer, it's for the customer, it's a natural language conversation-based interaction. And this is multi-turn, multi-pass. So anytime, for example, planner agent can go back to the understanding agent, basically asking for more information for the customer so that it can plan, better. And of course, we supply it with memory, knowledge, tools and APIs. For example, these tools would be calling dealer inventory in real time, or scheduling, API so that the dealer can actually, the customer can set up a time to come to the dealership to test drive a car. Even to do the tool calling, we had to do a bunch of work to make sure the LLM is calling the right tool in the evaluator agent part of it. Now, it turned out that this particular goal-oriented, planning and evaluation and explainer is actually very general purpose agentic framework. So now we are in the process of generalizing it and deploying it for many use cases at the company. Now, the first version of Chat Concierge was more of a custom built. We had a very limited time window, and we didn't feel like we have to build a whole ecosystem. We were not sure what the outcome would be. It was more of an exploratory work. Once we validated the idea, and once we started seeing good usage of it and ramping up in dealerships across the country, then we started to put together a plan for how do we now generalize it, how do we now build an agent ecosystem, an agentic platform, again, sitting on top of our AI platform core capabilities, so that we can really scale these agents everywhere in the company. That took us in the path that you see here. The last two ones, the GenAI core services and GenAI foundation services, were already kind of in place because of our AI work, like GenAI work. But a lot of the agent orchestrator, agent runtime, agent development kit, agent marketplace, application lifecycle management part of it, those are new things that we are continuing to build, and we have work to do here. But once we have that infrastructure in place, anybody in the company would be able to create their own agent, put it on our platform, and from that point on, using our SDK, Agent Development Kit, and then at that point, the platform will manage that agent on behalf of the user. And to us, again, it goes back to the enterprise platform idea that we don't want these things to be bespoke capabilities across the company. We want everybody to use the platform and scale agentic AI for all kinds of applications. So with that, I'm going to talk about a case study on agentic coding tools. I think everyone in this room has heard about like Cursor windsurf, Claude Code, anti-gravity, and so on and so forth. The example that I'm going to show you, it will talk about Claude Code, but it's actually a general blueprint. And at Capital One, we have been deploying a lot of these tools, and we are experimenting early days. We are learning a lot how to really embed these tools into our software development lifecycle. But all the things that I talked about being, enterprise platforms, data maturity, our focus on, risk management, automating a lot of our risk and cyber controls. All of these we see the same parallel as we deploy agentic coding tools at the company, that they are actually supercharging our ability to deploy these tools to our, 14,000 developers at the company. So the challenge is that bringing LLMs into any regulated enterprise environment creates a lot of inherent risks. And if you don't address the inherent risk, like you will spend a lot of time creating a lot of like meetings, documents, documenting risk, or you may have to accept certain risk, which are not always ideal. At the same time, when you look at how fast these agentic coding tools are moving, how quickly they are getting better at a lot of software engineering tasks, you don't have a lot of time to actually get all of these things in shape to be able to bring these tools inside the company. So what we did is that we created a kind of an architecture pattern that will be a zero trust AI environment for one of these tools, Claude Code, but using some of the native security of AWS Bedrock. And again, if you see a common theme in this whole talk is our ability to commingle first party, third party, and AWS together to build a solution quickly. And I'm going to skip this slide, but I'll come directly to this. And this is an example. Claude Code is a CLI. It's a little tool that you download on your laptop, and then it needs to have access to either Anthropic Claude.ai, their hosting platform, or access to Claude through Bedrock or some other provider. For us, the Bedrock choice was ideal because we are using the account level permissions and the Bedrock gateway as a enhanced security for us. We don't have to worry about, for example, whether the data that we are sending there would be used for training or not. There are a lot of reasons why you want to use something like Bedrock. For us, it's the time to market, the security implications, and the scale of Bedrock. And accessing, Claude, Sonnet, and Opus, et cetera, through the Bedrock ecosystem. Now, what we had to build ourselves is the AI gateway. That's where we focused on, because that's where we put our controls. We put, for example, token rate limiting. You don't want somebody to go in and kind of like spend $1 million worth of tokens in a single, offline task, because Claude Code is not same as like Cursor or Windsurf, where it doesn't need an IDE, right? You can write a batch job and you can say like go through these 20 repos and then do some task, do a code review or fix a bunch of things and come back. And you accidentally give it like a huge amount of context, and then you get a large token usage. So we have implemented a bunch of things, controls on our AI gateway. So, and we also built in a lot of like observability into the gateway so that we are doing a lot of detective control on the traffic itself. The other thing we are still learning. When you let an agent sit on your desktop, like developer desktop, it has access to a lot of your files and a lot of other information. So you have to create the right sandbox around it. But we don't want users to disable those settings. So we have a combination of like managed settings that we fix from the enterprise side. And then it also allows the developer to set certain settings on their own. Again, a lot of that infrastructure we had to build ourselves. But overall, we were able to bring this to market to live very quickly in matter of weeks, actually. Yeah. So where does it lead us? This is kind of like forward-looking. I think our focus on vertically integrated end-to-end stack will position us really well as new technologies come, new models come, new architectures come up in the research community. Our conscious decision of intentionally choosing a combination of open source, AWS, and third-party solutions that has worked out really well, and we think that it will also continue to work well for us. But we are here today because we spent a lot of time on designing our infrastructure in a way, our control plane in a way that allows us to be able to get these things from different places and to build kind of a hybrid platform. We have full control over our infrastructure. We don't depend on any particular vendor, etc. We can tune our stack very well at every level. And this idea of having custom models to custom hardware to custom pipeline to custom inferencing stack, or even if you take it to the agentic layer, that is where I think a lot of the leverage will come from. And then the way we are approaching our risk and cyber controls by automating them, by creating specialized environments where these agents can play, so to speak. And then we are extending these to all of the other capabilities that need AI, some kind of agent. For example, our data platforms. When our data platforms build data agents, they're not going to build a custom data agentic platform. They will start to leverage our own agent platform, for example. So we are extending the same control, same infrastructure everywhere there is a need for AI or infusing AI into that particular platform. Now, key to this is our ability to attract talent and develop them. I think if there is a single differentiator among companies going forward, it's really going to be the talent. We have been really lucky, fortunate enough to have the kind of the ecosystem and the environment and the culture to be able to be in a position where we can attract a lot of great talent. And one of the kind of like the validations of that, as I mentioned in Evident AI, 3 years in a row we have been #1 in AI talent. But we are not stopping there. In the last couple of years, we have really started to look across and forming partnerships with some of the most forward-thinking leading universities in the US. We have established research centers at USC, Columbia, University of Illinois, University of Maryland, and more recently, maybe around summer, we were the only bank and one of the 2 companies in the US that became partner to NSF AI institutes. NSF is awarding, I think, 5 academic groups, 5 national, Science Foundation AI institutes. We partnered with one of them, and we are the only bank there. And I personally see some of the benefits we have had. We have brought in a lot of faculty, a lot of summer interns. We just started an AI engineering internship program starting, from next summer. These are our pipelines, and they come in, they get to work on world-class infrastructure, they get to work with world-class scientists and engineers, and then, they are able to actually deploy something that has tangible value, that actually goes in front of our customers. So it's a great flywheel that we are creating in terms of talent. So I will end here saying it's an incredibly exciting time for us in the AI community and particularly at Capital One. As I said, I have worked at tech companies, but I just find Capital One to be such an amazing place to allow us to think big and then to be able to build this kind of infrastructure at scale. Thank you.